Hey y'all, welcome back. On tonight's homework, we're really not going to focus too much on what the notes covered, which is absolute extrema, but rather this homework is going to be a bit of a preview of our more formal midterm review that's coming up next class. So this is just a collection of mixed problems from all throughout the semester that you should know how to solve. So let's start with number one. It says, let f be a function given by this rational function here. If y equals 8 is a horizontal asymptote of f of x, then what does b equal? Well, notice there's a little unknown here, b, that we're trying to find. So to determine horizontal asymptotes, really what you should be asking is, what is the limit as x approaches infinity of this function? Okay, and so what this says is that that horizontal asymptote is y equals 8. And so essentially what it's saying is that the limit as x approaches infinity of this function is 8. And so the way to determine those horizontal asymptotes has to do with whether the numerator versus the denominator is growing faster. If the numerator is growing faster, then the infinite limit will not exist as x goes to infinity, because the value of the function will either increase to positive infinity or decrease to negative infinity. If the degree on the bottom is bigger, or if the denominator is growing faster, like if you have an exponential function versus a polynomial, for instance, then the overall value of the function is going to trend towards 0 as x goes to infinity, so the limit, or the horizontal asymptote, would be 0. Now, the only way to get a horizontal asymptote that is not 0 is to have a function where both the numerator and the denominator are sort of in the same class of functions. So in other words, like if you've got two quadratics, a quadratic on top and bottom like we have here, then the value of the horizontal asymptote, which will be the same thing as the value of the limit as x goes to infinity, will be the ratio of the leading coefficients. So what we need to do here is we don't have to multiply this completely out, but what we want to do is just multiply these first terms to compare the degrees of the numerator and the denominator. So in the numerator, we would have 2bx squared, and in the denominator, we just have x squared. Notice both of these are quadratics, and so the horizontal asymptote will be defined by the ratio of the leading coefficients, which in this case is 2b over 1. So 2b over 1 is going to equal 8, because y equals 8 is the horizontal asymptote. And then so if we divide both sides by 2, we can say that b is 4. Number 2 has a function that, if you're a little out of practice, you might be tempted to use the quotient rule on this term right here, but you really don't need to use the quotient rule here. Instead, rewrite that first term as 4 times x squared. I'm sorry, not x squared, but x to the negative second power. And then we can just apply the power rule to it. So 4 times x to the negative second plus 1/4 times x squared plus 4. Now if we want to find that derivative, we can just use the power rule. Negative 2 times 4 is going to be negative 8. So we have negative 8 times x to the negative 3. Recall that the exponent is going to decrease by 1. So that's why it becomes negative 3. So that's going to be the derivative of the first term. The derivative of the second term is 1/4 times 2, which is 1/2. So 1/2 x, and then the derivative of 4 is 0. So if we want to evaluate this at 2, f prime of 2, we're going to substitute in 2 into each of these x's. So we've got negative 8 times 2 to the negative third plus 1/2 times 2. And we'll have to evaluate this. Let me move this up a little bit so I can have a little bit more space to write this. But yeah, so 2 to the negative third power, that's going to be, like, if you know what 2 cubed is 8. So 2 to the negative third power is going to be 1/8. 2 cubed is 8. And then we've got this 1/2 times 2. So this arithmetic doesn't turn out to be too bad. We've got negative 1 plus 1 is 0. Number 3 says, for what value of x does the function have a local minimum? So in order for there to be a local minimum, f prime needs to go from being positive to negative. So we're going to have a sign change on f prime. So we need to figure out what f prime is. F prime is going to be 3x squared minus 18x plus, minus 120. Ugh, and that looks pretty ugly. We don't want to factor that just raw here. What we want to do is take out a GCF of a 3. So we got x squared minus, let's see, how many times does it go into 18? 6. Sorry about that. Yeah. And then, let's see, negative 120 is going to be negative 40. Okay, and so now what we want to do is factor that a little bit further. So I guess I'll continue this over here. F prime of x is equal to 3 times, and we can factor this now. The two factors are going to be x minus 10 and x plus 4. So the critical values are going to be at x equals 10 and x equals negative 4. So we have these two critical values, and a critical value is where you potentially have a local minimum or a local maximum, but you need to investigate a little further, first of all, to even see if it's an extreme value. But then secondly, this particular problem is looking for a minimum. So what we're looking for is the sign of f prime to go from positive to negative. So to just show our work here, I'm going to graph a little number line here for f prime, and I'm going to use these two numbers, negative 4 and 10, to be my partitions. And I'll just substitute some numbers in from each of these intervals and see if f prime is positive or negative. So we've got, we can ignore this 3, multiplying by 3 is not going to change the sign of anything. So really we're just looking at those two factors, and if I plug in something like negative 5, I'm going to have a negative times a negative is positive. If I plug in something like 0, I'm going to have a negative times a positive, which is negative. And if I plug in something like 20, I'm going to get a positive times a positive, which is positive. So we're looking for the x value where f prime goes from positive to negative. Right, we're going positive to negative, and that's going to happen here. And so the local minimum is going to be at negative 4. Number 3 is a limit problem, and you might be tempted to use L'Hopital's rule here, but you cannot, because if I substitute 3 in here, I don't get 0. Remember that if we want to use L'Hopital's rule, both the numerator and the denominator need to be 0 or undefined. Or infinity, rather. So we can't really use L'Hopital's rule here, but instead what we can do is just kind of analyze what's going on at x equals 3. Now, if I try to substitute in x equals 3 here, I am going to get 0 in the denominator, but not the numerator. So what that means is that instead of having a hole at x equals 3, I have a vertical asymptote on the graph. And so what we need to do is figure out what's happening around that vertical asymptote. Is the function going up? Is it increasing to infinity? Is it decreasing to negative infinity, or what? And we're going to have to check both sides of this asymptote, which is at x equals 3. So the simplest way to do this is just to take a number that is slightly to the left of it and then slightly to the right of it, substitute it into x, and get an idea of whether or not the function is going up or down by establishing if it's positive or negative. So if I plug in a number like, say, 2.9, like right on the left-hand side of 3, if I plug that in here and here, I'm going to get a positive divided by a positive is positive. So likely what's happening here, and really to be sure, you got to plug in more values. But I think, if you go right to the left of it, that's usually good enough. We're going to assume that this is going up to positive infinity. If we plug in a number like, say, 3.1, which is just to the right of x equals 3, we're also going to get a positive number. So on either side here, the function is going to be going up to infinity. So if the arrows are going in the same direction, then that's going to be our answer here. We're going to say infinity. Now, from a technical standpoint, I really am not crazy about these answer choices here. And the reason for that is, let me move all this over a little bit. The reason that I'm not like super crazy about these is because technically the limit does not exist here. Anytime you've got a vertical asymptote, whether or not the arrows are going in the same direction, just from the definition of a limit, it will not exist. But typically on a multiple choice item, you're going to have to decide if it's positive or negative infinity. So if they're both going up, you say infinity. If they're both going down, you say negative infinity. And if you get something like this where they're going different directions, you would say does not exist. But I don't think I could be wrong about this. I'll double check and I'll put a little note in the comments if I'm wrong. But I don't think they write answer questions like this with answer choices with this kind of ambiguity. It would either be like, hey, choose between plus or minus infinity, or choose between existing or not existing, not choose between positive or negative infinity and does not exist. But on this particular problem, infinity is the best answer, even though technically the limit doesn't exist. Okay, that could be a little confusing there, but number 5, determine the equation of the tangent line. So right away, I'm not even reading the rest of the problem before I set myself up here. I'm looking for a point. I'm looking for a slope, and I can use that point and that slope to write my tangent line. So it says to the graph of y equals f of x at the point where x equals negative 3, f of negative 3 is 2, and f prime at negative 3 is 5. So the point here is going to be at negative 3 comma 2. We don't actually have the function, but we do have the point, negative 3, 2. And the slope is going to be the value of the derivative at negative 3. And you don't have to find that either. They actually give it to you. It's 5. So my equation is going to be y minus 2 equals 5 times x plus 3. That's the point slope form of the linear equation. But you'll notice that none of these answer choices are in point slope form. They're all in slope intercept form. So we're going to have to simplify this a little bit. I'm going to distribute the 5, and that'll give me y minus 2 equals 5x plus 15. And then I'm going to, I don't know why this keeps jumping around like that. We're going to add 2 to both sides. And this should be our answer. Y equals 5x plus 17. So our answer is B. Number 6 says, let f be a twice differentiable function such that the second derivative is negative. So when I see that in the problem, right away I'm thinking, okay, well, f is concave down. That's what the second derivative being negative means. It's sort of like coded language for what they're trying to communicate. The graph of y equals s of x is a secant line passing through the points 3 comma f of 3 and 5 comma f of 5. The graph of y equals t of x is the line tangent to the graph of f at x equals 4. Which of the following is true? So I think if you just like make a quick sketch of what's happening on this function, it'll be a little bit more obvious. So let me show you what I mean by that. So let's say we know f is concave down the whole time. So an example of that would be like this. I'm not saying that this is for sure what the graph looks like, but we can sketch any concave down curve and should be able to get the right answer here. So what we have is first a secant line. Okay, secant line as opposed to a tangent line. Let me maybe draw the tangent line first, since we do that more often. It says that there's a line tangent to this that we'll call t of x, and it's tangent to the curve at x equals 4. Okay, this curve is going to be my f of x. A secant line, instead of touching the graph at just one point, it passes through the graph at least 2 points. So we've got this secant line here, which I'll call S, that's intersecting our function at 3, f of 3, and 5, f of 5. Now what this question is asking is to compare the values of f, s, and t when x is 4.2. Now 4.2 is just to the right of 4. It would be like 4.2 is roughly here on this little sketch. And so what we're doing is we're comparing the values of f, s, and t. Well, here's the value of s, here's the value of f, and here's the value of t. So the smallest one would be s, the largest one would be t, the value of t, and the one in the middle is f. So the answer here is C. Number 7 is just a straight up derivative problem. We're going to have to use the quotient rule here. So the quotient rule says that we take the derivative of the top, which would just be 1, times the bottom, minus the top times the derivative of the bottom, which would be 2x. All of that divided by the bottom squared. So it looks like, unless there's some factoring shenanigans that are going to happen, it looks like we're just going to simplify this and hopefully we see our answer choice. So the numerator is x squared plus 1 minus 2x squared minus 2x over x squared plus 1. Oops, I forgot the squared. My bad. Equals x squared, x squared minus 2x squared is going to be negative x squared minus 2x plus 1 over x squared plus 1 squared. So I'm looking through my answer choices, and I do see my answer here is A. Number 8, we have the natural log of the natural log of x. Determine the derivative of f. So this is going to be a little chain rule here. Just remember that the derivative of just regular old natural log x is 1 over x. So what we need to do here is say it's 1 over, so if our f prime is going to be 1 over the inside, which is natural log of x, times the derivative of the inside, which is natural log of x. So the derivative of natural log of x is 1 over x. And that's pretty much our answer. We just need to combine the two fractions. So 1 times 1 is 1, and x times natural log of x is just that. So our answer is C. Number 9 says the graph of f prime, the derivative of the function of f is shown in between -3 and 3. On which intervals is f increasing? So in order for f to be increasing, f prime has to be positive. All right, the slope of f is positive, and that's what the derivative is. Now this is the graph of f prime, and so we can see that it's positive here all the way here. Now you might be a little worried to include 2 here, but what would have to happen in order for the derivative to be 0 just at a point is you would have like a positive slope that slows down and just instantaneously becomes horizontal and then continues to be positive. And so it's okay to just say, hey, the interval here is going to be from -1 to 3, or B. Now, if you wrote this a little differently, if you wrote from -1 to 2 and 2 to 3, that would be okay as well. I do not believe you're going to see a multiple choice question where both of these are options. I think -1, 3 is really like the better of the two options. But if you wrote these two intervals separately, that's not a big deal. Number 10, we have a little inverse action going on here. We have h is a function defined as the product of x and g, where g is the inverse of f. Use the table of values to find h prime of 5. Okay, so first of all, we need to find h prime. So h prime, we're going to have to use the product rule here, is the derivative of x, which is 1, times g of x, plus x times the derivative of g of x. Now, if we're going to use this table, you might want to go ahead, and I'm going to erase this 1, you might want to go ahead and actually figure out what g prime is. Like, what is the derivative of the inverse of f? So the derivative of the inverse of f, so g prime, is going to be 1 over f prime g of x. So I think I'll go ahead and write h prime as g of x plus x times that would be like x over f prime of g of x. Okay, so if we are trying to figure out h prime of 5, what I need to do is plug in 5 into x. So h prime of 5 will be g of 5 plus 5 divided by f prime of g of 5. So let's take a look at that table and figure out what is g of 5. Well, if 3 comma 5 is on f of x, then 5 comma 3 is on the inverse of f of x. So 5 comma 3 is on g. In other words, g of 5 is 3. So let's evaluate that. We've got 3 plus 5 over the derivative of f at 3. Now, the only thing we really need to find here now is the derivative of f at 3, and that is a value given in the table. Here's where x is 3, here's the derivative, so the value is 2. So this is going to equal 3 plus 5 halves. 5 halves is 2.5, so 2.5 plus 3 is going to be 5.5. Number 11 says the slope of the line tangent to the graph of this natural log function at x equals -1 is. So what we need to do to find the slope of the line is to find the derivative of this and then plug in -1. So y prime is going to be 1 over 1 minus x times the derivative of 1 minus x, and that would be times -1. And so now we're going to evaluate this at -1. So we're going to evaluate y prime at x equals -1. And so that would be 1 over 1 minus -1 is the same thing as 1 plus 1. So 1/2 times -1 is -1/2. Finally, number 12, it says, what are all the values x for which this graph is concave down? So we need to find when is the second derivative negative. So let's find the first derivative. Y prime would be 3x squared minus 12x. Y double prime, which is really what we're interested in here, is 6x minus 12. So to find when it's concave down, we need to find the intervals where f double prime is negative. So let's find when it's 0, like where those inflection points may be. If I set this equal to 0, 0 equals 6x minus 12, then x is going to be, 12 divided by 6 is 2. So on my number line chart, my sign chart for f double prime, I'm going to put 2, and now I'm just going to substitute some values on either side of 2 into my second derivative to determine the sign of it. So if I substitute in 0, I'm going to get a negative, and if I substitute in something like 10, I'm going to get a positive. So it's concave down in between -infinity and 2. Or another way of saying it is all x values less than 2. So our answer is E. And that about wraps it up. This is just really more of like an introduction to our midterm review. Like I said, we're going to get that next class, and so we'll work through that in good time. But please let me know if you have any questions on any of these problems. I'll be happy to go into more detail. Other than that, y'all have a great day, and I'll see you next time.